This is that little brief summary video I told you that we produced. Make sure you knew how to study Chapter 1 material for the history of ecology, the important ecologists, their approximate year or period of discovery and work, and then their main contribution. Then we'll go into a little detail explaining again Shelfords' law of tolerance and the graph. But again, we said make sure you know the last name of the researcher, the approximate year, and the main contribution. So as your book points out, Wildenau, around 1800, plant geography. Malthus affected Charles Darwin's theory development, as we saw in Chapter 1. He's expounded more in Chapter 5 as well. Around 1830, the idea that food limitation could limit population growth. Von Liebig, the law of the minimum, 1840, and then of course Darwin, Origin of Species, took the voyage on the Galapagos. The HMS Beagle was the ship that he found evidences that looked like natural selection in affecting the success of certain genotypes and their resultant phenotypes to survive and eventually maybe produce cumulative changes that could be new species. Ernst Haeckel, your book points out in Chapter 1, around 1866, coined the word, German word, Ecology, which is the English word ecology. Carl Möbius, 1877, saw the concept of a community which was in an oyster-reef, the biosynosis. We go on and we see all the rest of these we've gone over. Make sure you know that same approach to knowing the name, the year, and their main contribution. Eventually coming down to Rachel Carson, 1962, created the environmental movement with her famous book, Silent Spring. She was a marine biologist, similar training to me, much more famous, of course, and The Silent Spring was a landmark novel that showed the silence due to the birds no longer around to sing in the springtime because DDT was killing them. And then the famous Odum brothers, Eugene Odum and H.T. Odum, 1960s and 70s. I had the honor and privilege to be trained by some of the H.T. Odum School of Ecology. I've met Dr. Eugene Odum in person, but my major professor in graduate school was B.J. Copeland, who trained directly under H.T. Odum. Okay, well, let's go now to Shelfords' law of tolerance graph and make sure you're clear on that. Shelfords' law of tolerance is the whole concept that too much or too little of a condition can be harmful. So we know that we have an optimal range of temperature, for instance. So if the x-axis is the environmental condition, say temperature, we know that we have a preferential temperature range. We know that if you go out to the extreme deserts, extreme example in this country would be Death Valley in California, below sea level, no water, high sun intensity, dehydration, can't survive there. We go way up north with extremely low temperatures, same thing. So we have an optimal zone. This is the condition for really any environmental factor. Plants have soil pH range. If it goes too low, it's too acidic. If it goes too high, it's too basic. Now, if you plot experimentally how many plants should survive for a particular pH, we see the number of survivors goes up, up, up when you're in the optimal zone. And then it drops down as you move into too high a pH. So that creates the concept we said of TL50. Buttons didn't want to cooperate there. So we see you have TL50. That stands for tolerance limit at which you have 50% survival. So they look over on the percentage or number of individuals surviving. Midway is about 50%. You go straight over to your curve and then straight down to the condition, and that would be a TL50, a lower TL50. You go over all the way at the 50% level to the upper range, and you drop it down, and that would be a condition which would be the tolerance limit 50% for the upper condition. In drug testing, such as with the COVID-19 vaccine, we use an LD50 in clinical trials, and that's the lethal dose that you get 50% survival. The lower lethal dose, LD50, and the upper LD50. Now, we don't do these people. We don't go and see we have 50% people dying. No, they test them in early phase clinical trials on laboratory animals, as we mentioned. And then there's just that repeat of Liebig's law of the minimum, which is the whole concept of the limiting factor. When you have a condition of whatever of the different environmental, physical, chemical needs that a species has to survive, whatever one is too low in relative to its need by the organism, that would be the limiting factor. So that concludes this little extra explanation about Shelfords law of tolerance. And so I hope it's been helpful to you. Let me see if I can